Hello everyone, in this video we'll see how to solve some numericals on electricity chapter of class 10. See, let us see, before going for solving the numericals, let us see the list of the formulae on electricity. The first physical parameter, the second one is formula and SI unit and the name of the SI unit. What is the formula for the electric current? Electric current can be written as charge divided by time. Electric current is represented by I and charge is represented by Q and time is represented by T. I is equal to Q by T is the formula for the electric current, and the SI unit of the charge is coulomb and SI unit of the time is second. This coulomb per second is giving what? Ampere, and this is ampere symbol is capital A. Potential difference formula, that is work done divided by charge. V is equal to W by Q, where V is the potential difference and W is the work done divided by charge. Q is charge. SI unit of the work is joule and charge is coulomb, that is volt, and it is volt. Ohm's law. Ohm's law says that V is equal to Ri, that is V is directly proportional to I, where R represents the constant, and SI unit of the resistance is ohm and current is ampere, and this SI unit of the potential difference is V, that is volt. Effect resistivity, that is resistivity rho is equal to Ra divided by L. We know that resistance is having SI unit ohm and area unit is meter square and length unit is meter, and ultimately 1 meter and 1 meter will get cancelled and it gives a SI unit of ohm meter. And effective resistance in series, that is Rs is equal to R1 plus R2 plus R3 plus so on plus Rn. If there are more than one or two resistors are connected in series, then this is the formula we have to go use, and its SI unit is ohm, and effective resistance is 1 divided by Rp is equal to 1 divided by R1 plus 1 divided by R2 plus 1 by R3 plus so on plus 1 divided by Rn. Power input to the circuit, we know that power is equal to what? Rate of doing work, that is work done divided by time. Already you know this. From this formula we can write W is equal to what? Q into V. From this I can write, I am writing the same thing, W is equal to V into Q, and Q by T is what? Q by T is I. Q by T is equal to I, that is current. I am writing the both of here. Therefore P is equal to V into Q divided by T. Q by T is what? Q by T is VI. Therefore Q power is equal to V into I. SI unit of the power is watt and its symbol is W. Amount of heat produced, that is H is equal to VIT, that is heat produced is equal to H is equal to VIT. From Ohm's law we know V is equal to IR. V is equal to IR into IT, that is I into I square, R into T, RT. Therefore the SI unit of the heat producer is joule. See, these are the list of the formula you have to remember. Let us go for the next problem, how to solve the numericals on the problems. The first one on electricity chapter, that is the numerical first. If 20 coulomb of charge pass a point in circuit in 1 second, what current is flowing? How much charge he had given? What he had given in the problem? Charge, that is charge is equal to charge, that is Q is equal to 20 coulomb he had given, and time period, that is time small t is equal to 1 second. What is asking in the problem? To find the current, to find I is equal to how much, that is current. Therefore we know that electric current I is equal to Q divided by T, that is charge divided by time. What is the charge here? 20, and what is the time here? 1. 20 by 1, that is 20 coulomb per second, that is 20 ampere. Current flowing through the point is how much? 20 ampere. 20 ampere is the answer. Let us go for the next question now. How much work is done and 1 coulomb charge is moves against a potential difference of 1 volt? Given what he had given in the problem, charge, that is Q is equal to 1 coulomb, that is charge he had given 1 coulomb, and potential difference, that is V is equal to 1 volt, that is charge he had given 1 coulomb and V he had given 1 volt. And how much work he is asking to find what work is how much? We know that What is the formula for potential difference? Potential difference is equal to work divided by charge. Work divided by charge, and we know that V is equal to W divided by Q. So therefore V is equal to how much you had? V is equal to W by Q. V is 1 volt and W is we have to find, and Q is 1 coulomb. Therefore W is equal to 1 into 1. How much it is? 1 joule of work is done against, and 1 coulomb of charge moves against the potential difference of 1 volt. How much work is done? Go for the next question. How much work is done in moving a charge of 2 coulomb? In moving a charge of 2 coulomb. What he had given in the problem? How much? Again, what he is asking? Work is equal to, that is work W is equal to question mark a charge. Charge is given as 2 coulomb and potential difference of 12 volt. We know that V is equal to W divided by Q, and V is equal to 12 volt and W we have to find, and Q is 2. So therefore work done is equal to 12 into 2, that is 24 joule. Work is done in moving a charge of 2 coulomb across 2 points having a potential difference of 12 volt. What is the answer? 24 joule is the answer. Let us go for the next question now. Calculate the work done in moving a charge of 4 coulomb from a point at 220 volt to another point at 230 volt. What he had given, see, if in an electric circuit we have to move the charge of 4 coulomb, we have to move the charge of 4 coulomb from 220 volt to 230 volt. He had given the potential difference. How much he had given potential difference, that is V2 minus V1. V2 is how much? 230 minus 220. 230 minus 220 is how much? 10 volt. That is potential difference he had given 10 volt, and charge he had given, charge Q is equal to 4 coulomb. Charge Q is equal to 4 coulomb, and we know that calculate the work done. Work is equal to question mark. We know that potential difference V is equal to W divided by Q. So therefore W is equal to Q into V. Q is how much here? 4, and potential difference is 10. 4 into 10 is 40 joule. That is work done is equal to 40 joule is the answer for the question. Let us go for the next question. How much energy is transferred by a 12 volt power supply? What he had given in the problem, potential difference V is equal to 12 volt he had given, and charge Q is equal to 1 coulomb. That is each coulomb means what? 1 coulomb. H it moves around a circuit. That is work done is equal to question mark. To find what? Work done is equal to question mark. We know that potential difference V is equal to W by Q. Therefore W is equal to V into Q. V is how much here? V is 12 volt and Q is 1, that is 12 joule. That is W is equal to 12 joule is the answer for the given question. Let us move for the next question now. What is the potential difference between the terminals of a battery? What is the potential difference? What is asking in the problem? To find potential difference V is equal to question mark. Potential difference V is equal to question mark between the terminals of a battery. Work done is equal to 250 joules is required to transfer charge of 20 coulomb from one terminal of a battery to the other terminal of the battery. See, that is potential difference. We know that potential difference V is equal to W divided by Q. W is 250 and charge is 20. This 0 cancels. 25 by 2, that is 2 ones are 2 twos are 0.5, that is 12.5 volt. Potential difference is how much? 12.5 volt is the answer for the given question. Let us move for the next question now. 3 2-volt cells are connected in series and used as a battery. We know that group of cells is known as battery. This is one cell, and this is second cell, and this is one more cell. How many cells are there? 2 volt, 2 volt and 2 volt. What is the potential difference and used as a battery? What is the potential difference at the terminals of the battery? Answer is, the potential difference at the terminals of the battery is 2 plus 2 plus 2. Simply you add them. How much it is? 6 volt. How many joules of electrical energy does 1 coulomb? Given what is given? 1 coulomb. Q is equal to 1 coulomb on gain on passing through the one cell. One cell means potential difference is for one cell. How much he had given? 2 volt. And what he is asking, how many joules of electrical energy, means work is equal to question mark. Work or energy, both are same. Work is equal to energy. What is work? The rate of the capacity to do the, what is energy? The capacity to do the work is known as what? Energy. If you have the energy, then only you can work. And what is the unit of energy, work and heat? All of them are having the same unit, that is joule. We know that potential difference V is equal to W by Q. V is given as 2 volt, that is V is given as 2 volt, and work we have to calculate, and Q is given as 1. Therefore W is equal to 2 into 1, that is 2 joule is the answer for the given question. When one cell is used, when all the 3 cells are used, when all the 3 cells are used, what is the potential difference? 6 volt. And what is the charge here given? For 1 coulomb only he is asking. We have to find work done. Work done is equal to question mark. We know that V is equal to W by Q, therefore W is equal to V into Q, and work is equal to V is how much here? 6 volt, and Q is 1 coulomb. 6 into 1, that is 6 joule. W is equal to 6 joule is the answer for the given question. Let us move for the next question. A current of 4 ampere flows across a circuit of 10 seconds. Given what he had given in the problem, current I is equal to 4 ampere, time for 10 seconds he had given, and how much charge flows past a point in the circuit. Q is equal to question mark. We know that I is equal to Q by T. I is how much here? 4, and Q we have to find, and time here is 10 seconds. Therefore Q is equal to 4 into 10, that is 40 coulomb is the answer for the given question. Let us move for the next question now. What is the current in a circuit if the charge passing each point is 20 coulomb? What is asking to find? I is equal to question mark. If charge is given, what he had given, charge is equal to, that is Q is equal to 20 coulomb, and time period is 40 seconds. We know that I is equal to Q divided by T. I is equal to Q means how much? 20 divided by 40. 0 0 cancels, 2 1s are 2 2s are, that is 1 by 2. I is equal to 1 by 2. Therefore I is equal to 0.5 ampere. I is equal to 0.5 ampere is the answer for the given question. Let us move for the next question. If a potential difference of 10 volt causes, given potential difference he had given 10 volt causes a current of 2 ampere to flow for 1 minute. We should convert minute into seconds. So 1 into, in 1 minute how many seconds are there? 60 seconds. 60 into 1, that is 60 seconds. How much energy is required? How much energy is transferred? That is W is equal to question mark. We know that V is equal to W by Q, therefore W is equal to V into Q. V is given, Q is not given, but to find Q I can use I is equal to Q by T na. I is equal to Q by T. What is I here given? Q is equal to I into T. What is I here given? I is equal to 2 ampere and time is 60 seconds, that is 120 coulomb is the charge. Therefore W is equal to V into Q. W is equal to V into Q. V is 10 and Q is 120. This is 1200 joule, that is 1200 joule. Therefore the answer is 1200 joule. A next question, let us move for the next question. A reduce that draws a current of how much, what he had given to find, and given what he had given in the problem, current how much he had given, 0.36 ampere, and time period how much he had given, 15 minutes. So 15 minutes, that is 15 into 60 seconds, right? And 15 into 0 is 0, 15 6 90, 900 seconds he had given. And calculate the amount of electric charge, Q is equal to question mark, and we know that I is equal to Q divided by T. Q is equal to I into T. I is how much here, 0.36 into 900. See, when we multiply 0.36 into 100, that it becomes 36 into 9. Therefore Q is equal to 36 into 9. 9 6 are 54, 9 3 are 27, plus 5 32, 324 coulomb is the answer for the given question. So let us move for the next question. The potential difference across a lamp is how much had given, potential difference he had given, P is equal to 12 volt. How many joules of work to find work is equal to question mark are changed into heat and light when a charge of 1 coulomb, Q is equal to 1 coulomb. See, to find, we know that what is the formula for the potential difference, V is equal to W by Q. Therefore W is equal to V into Q. P is how much here, 12. Q is 1, that is 12 into 1, that is 12 joule. That is 12 joule is the answer. That is 12 joule is the answer for the given question. 12 joule is the answer for the given question. Let us move for the next question. A charge of 5 coulomb passes through it, and Q is equal to 5 coulomb he had given. We know that W is equal to V into Q. V is again how much he had given, 12, and Q is given as 5. 12 into 5 is 60 joule is the answer for the given question. For potential difference of 12 volt and current of 2 ampere, and for 10 second, what he is asking, work done is equal to question mark. We know that V is equal to W divided by Q. Therefore W is equal to V into Q. V he had given, W, Q is not given. Therefore for this I make use of the formula electric current is equal to I is equal to Q by T. I is equal to Q by T. I is how much here, Q is equal to I into T. I is how much here, 2 into time is 10. 20 coulomb is the electric charge. Therefore W is equal to V is how much here, V into Q. W is how much, V is how much here, 12, and Q is 20. 20 into 12, 240 joule is the answer. Work done is equal to 240 joule. Work done is equal to 240 joule. In 10 second, let us move for the next question. In 10 second given, in 10 second T is equal to 10 second. In 10 second given time is equal to 10 second, a charge that is Q is equal to 25 coulomb, and in energy that is W is equal to 200 joule are delivered to an circuit as a result. What is the potential difference? Potential difference V is equal to question mark. We know that V is equal to W divided by Q. W is how much, 200 divided by 25. 25 on the 25 8, that is 28 volt is the answer. V is equal to 8 volt is the answer. Next question. What current flows from the battery? That is I is equal to Y is equal to question mark. That is I is equal to Q divided by T. Q is how much, 25, and time is how much, 10 seconds. That is 2.5 ampere is the answer. 2.5 ampere is the current. A flash of lightning carries a 10 coulomb of charge. Given what had given in the problem, Q is equal to 10 coulomb, which flows for time is equal to 0.01 second. It can be written as 1 divided by 100 second. What is the current? I is equal to question mark. If the voltage is 10 megawatt, 10 megavolt, 10 into 10 to the power 6, mega means how much? 10 to the power 6 volt. What is the energy? That is W is equal to question mark. We know that, dear students, I is equal to, what is the formula? Q by T. And electric charge how much had given? 10. And the time is 1 upon 100. So when 100 goes to the numerator, 10 into 100, how much it is? 1000 ampere. I is equal to 1000 ampere. Current is equal to 1000 ampere. And we know that V is equal to W divided by Q. He is asking W is equal to V into Q. V already he had given 10 into 10 to the power 6, and current electric charge how much had given? 10. 10 into 10, 100 into 10 to the power 6 joule. You can write again 100 into 10 to the power 6 is mega joule. 100 megajoule is the answer. Let us move for the next question. An electric heater is connected to the 230 volt main supply. That is potential difference how much he had given? 230 volt potential difference. A current of 8 ampere flows through the heater. How much charge flows around the circuit each second? T is equal to 1 second. We know that potential difference V is equal to W divided by Q. V is equal to W divided by Q. And I is equal to what? Q divided by T. I is equal to Q divided by T. He is asking Q. No? Q is equal to I into T. I is how much? 8, and time is 1 second. That is charge is equal to 8 coulomb. That charge flows through the 8 coulomb flows through the circuit each second. How much energy? That is W. He is asking the W is equal to question mark. We know that V is equal to W by Q. So therefore W is equal to V into Q. V is how much had given? 230 volt for the same question, and Q is how much here? 8 coulomb. That is 8 0 0, 8 3 24, 8 2 16 plus 2 18. 1840 joule is the answer for the given question. 1840 joule is the answer for the given question. How many electrons are flowing per second past? Electrons are flowing per second. Time is equal to 1 second past a point in a circuit in which there is a current of 5 ampere. I is equal to 5 ampere. To find how many electrons, to find electrons is equal to question mark. To find electrons is equal to question mark. I is equal to Q divided by T. We know that Q is equal to I into T. I is how much here? 5 into time is how much? 5 coulomb. See, we know that 1 electron is equal to 1.6 into 10 raised to minus 19 coulomb. For 5 coulomb, how many electrons are there? I am taking it as an X. X is equal to, therefore 5 into 1 whole divided by 1.6 into 10 to the power minus 19. How will you write this? 5 into, see, when it goes to the numerator it becomes 10 to the power plus 19, and whole divided by 1.6. I am writing it as a 16 divided by 10. 10 goes to the numerator into 10. See, therefore it becomes 5 into 10, 50 divided by 16 into 10 to the power 19. See, therefore 16 ones are 16, 16 threes are 48, and 2 is remaining. 16 ones are 16, 4 is remaining, 16 twos are 35, 8 is remaining. 5 into 10 to the power 19 electrons are there. 3.125 into 10 to the power 19 electrons are there in the given problem. Let us move for the next question. Calculate the current in passing 10 coulomb. I is equal to question mark in passing 10 coulomb, that is 10 coulomb for 5 seconds. I is equal to Q divided by T, that is 10 divided by 5, that is 2 ampere is the answer for the given question. Thank you for listening. Thank you for listening and watching the videos. If you like the video, please do subscribe and subscribe the button, and if you like this, share the video to others. Thank you and have a nice day. The next problem, if the charge on an electron is, Q is equal to 1.6 into 10 raised to minus 19 coulomb he had given, how many electrons does it require? The number of electrons we have to find. How many electrons are required? Should pass through a conductor each second for time is equal to 1 second to constitute a current of 1 ampere. To constitute a current of 1 ampere, we know that I is equal to Q by T. Dear students, we know that I is equal to Q by T. See, therefore Q is equal to what? I into T. I is how much here? 1, and time is how much here? 1. See, therefore it becomes 1 coulomb. 1 coulomb. Already you know that. For 1 electron is giving how much charge? 1.6 into 10 raised to minus 19 coulomb. And for 1 coulomb, how much charge is there? I am taking it as an x. We know this by unitary method. How will you do this? X is equal to 1 into 1 divided by 1.6 into 10 to the power minus 19 coulomb. See, 1 into 1 is 1, and 1.6, how will you write this? 16 divided by 10, and I am taking this 10 to the power minus 19 to the numerator. It becomes 10 to the power 19. See, therefore what happens now? See here, 10 goes to the numerator. 10 divided by 16 into 10 to the power 19. So this one becomes 16 ones are 16 point 16 six are 96, 4 remains, 16 twos are 32, 8 remains, 16 fives are 30. 0.625 into 10 to the power 19 electrons are 6.25 into 10 to the power 18 electrons are there in 1 coulomb of charge. This is the answer for the given question.